the sessions. The next talk is by Divyarthi Mohan on simplicity and optimality in algorithmic economics.
Okay. Hi everyone, I'm Divya, and I'm a postdoc currently at Tel Aviv University, and I work with Michal Feldman. And of course, I'm a research fellow here for the semester with the graph limits and processes on networks program. So my work broadly lies in the intersection of like algorithms, economics, and game theory. And like especially I'm interested in understanding the role of like simplicity or like the effects of simplicity in these regimes. And like when simplicity can lead to like good outcomes. So I will briefly talk about like what I mean by this initially, and then I'll like give a little bit more detail about like one of my work. Okay, so obviously algorithms are everywhere, and like they have changed our worlds like drastically. Like we use algorithms to find the best possible routes to our destination, match drivers to passengers, and even like operate self-driving cars in busy cities. But in many of these settings, algorithms are not just finding the best possible solution while using the resources efficiently. They do so while interacting with strategic or autonomous individuals who have their own interests, so they might interfere with or manipulate the algorithm. So it's important to design algorithms that not just give good performance guarantees, but are robust to strategic behavior. And that's what the field of algorithmic game theory focuses on. And like my work especially looks at the case beyond single dimensional settings. So like I work in multidimensional mechanism design, where optimal mechanisms can be very complex and computationally intractable. So I'm interested in learning like or understanding and designing simple mechanisms that get good outcomes. That is, they are approximately optimal. And more generally, the field of algorithmic game theory like studies how systems or algorithms perform in strategic environments. And like here, like my interests have been like mostly in understanding how strategic agents or like agents in a network interact and like communicate and learn from each other. And what are the effects of these? Like, can we understand real world phenomena such as like polarization or like misinformation and information propagation using these models? So this is the part I'm going to focus on today. This is joint work with Nika Haktalab, Nicole Imarlika, Brendan Lucier, and Marcus Mobius. We study strategic communication with anecdotes. So we look at a standard economic model of communication. We have a sender and a receiver and a hidden state of the world theta. Okay. So the sender is more informed. He gets some private signal about the state of the world, and then he's going to communicate something to the receiver. And the receiver hears this and makes a like rational update. She updates her belief like in a Bayesian way, let's say, and then she's going to take some action A. And both the agents are going to then receive their own payoffs. And like importantly, the payoffs can depend on both the state of the world theta and the action taken by the receiver. So the sender here is more informed. So there is information asymmetry, and he can maybe like choose to say something to like manipulate the receiver in some sense, because receivers has the agency to take the action, and that influences both the sender and the receiver. Okay, so for example, you can think of the case where like the sender is a newspaper, and like they want to like communicate to the readers who are the receivers about like the dangers of like long COVID, and like maybe reading these, like the readers are going to update their beliefs and take an action on like how much should we like wear masks, or like whether we should get vaccinated or not. And like in our model, we are interested in understanding this game when there are anecdotes at play. So by that, I mean that the sender is going to observe some anecdotes about the state of the world theta, and then he's going to share one of the anecdotes about like that he observes. So here we think of anecdotes as like immutable stories or like facts the sender can share from like whatever he observes, but he cannot make them up. He can't fudge them up. He can't like summarize them or anything. He's going to like share one of the anecdotes that he observes, and like he'll choose which one to like share it with the receiver. So more concretely, again, we have a sender and a receiver, and a hidden state of the world theta. So assume for this talk that the sender knows theta and gets and gets anecdotes that he can share. He can't like share theta, but he can share the anecdotes, and anecdotes are just modeled as like samples from a distribution that is like centered around theta. It's like noisy signals about the state of the world with like the mean zero noise and like symmetric. And he's going to choose one of the n anecdotes to share. And then the receiver will hear this and take an action. And we are going to look at the payoffs as like coming from what the sender and the receiver's ideal actions are going to be. So the sender is going to have their own ideal point. He wants the receiver's action to be close to some theta plus some number, ms. And then the receiver has her own ideal point, which is like some shift of theta plus ms. And like they both want to like maximize their payoff or like minimize the distance between the actions to their own ideal points. Okay. So, and the strategy space of the agents are as follows here. So the sender's strategy space contains like communication schemes, which will take the n anecdotes and map it to one of them. So it's just a function that takes a realization of the anecdotes and maps it to one of the anecdote. And the receiver strategy space contains action rules that take the communicated anecdote from the sender and maps it to some action. Okay, so this is like the communication game that we are going to study. And the high level questions that we are interested in is, what do we communicate? Like, is there going to be bias in the anecdotes that we communicate? And how efficient is this whole like communication with anecdotes? Is there, how will the communication be effective or like informative? How accurate is it going to be? And also we want to understand the other effects of like, who are we going to communicate with? Like, is there going to be belief polarization, or like, is there going to be some preferences for communicating with certain kinds of senders or receivers over others? So our results are as follows. I'll keep it very brief. So we first characterize like best responses, and we see that there is this very nice equilibrium structure, like a perfect Bayesian equilibrium, where the sender's communication strategy is this simple biasing strategy. Like his strategy is just going to be to pick a shift of theta, like that's going to be some point, and send the anecdote closest to theta. That's it. And the receiver is going to best respond by like debiasing this anecdote and takes an action which is basically going to be a shift of the received anecdote. Okay, so it's like we don't have this as like a constraint on the communication schemes. The sender can choose any anecdote to send, but we see that this is a nice refinement with a very natural property where we can think of how we communicate, like how there are biases in our communication. And we see that in the equilibrium, depending on how different the sender and the receivers are, this shift of theta the sender chooses, or like the bias of the anecdote that the sender chooses, grows with the difference between the preferences of the agents. And because of this increasing like bias, we also see that the variance of the communicated communicated anecdote is going to increase. So there is a loss of precision as the bias increases. So as the sender and the receivers are getting more and more misaligned, like there is going to be more and more information loss along with the bias in communication. And we see that this is not the case when the sender has a power to commit. So when the sender can commit, like in a sequential game, the optimal strategy is actually to choose an unbiased anecdote that is closest to the state of the world theta, instead of like trying to bias it and like the receiver debiasing it, because that only leads to loss in precision. So the sender does not even want to do that. So we see that like even in the simple model of like communication, there are these very interesting insights about like real world phenomena such as like information homophily. So recall that when the sender and the receiver are misaligned, there is bias at equilibrium, right? There is a biased anecdote that's being sent, but since it's still a realized signal, the receiver is still learning. So in our model, the receiver is debiasing it and learning, and there's information learned. But because of the loss in precision, the receiver quality of information that she receives is going to be worse as the sender and the receiver diverge. And this affects both the agents' payoffs. Both the agents suffer a loss when their types are misaligned. And we see that because of this, there are cases where the receiver might actually prefer talking to someone with very few observations, like constant number of anecdotes, who's perfectly aligned with her, over an expert who has like a lot of information, but since they are like a little bit misaligned from the receiver, they can like choose an extreme anecdote that has like very bad precision. Like even if the receiver is able to debias it, it's just such a noisy signal that like she prefers listening to someone with like 10 anecdotes who's exactly like her over someone who's an expert who's like misaligned from her. And I think like this sort of like phenomena where rationality can explain like homophily is super interesting. And this is something I would like to like understand better in terms of like the effects of these kinds of informational homophily and how they affect like social network formation and like how we evolve when we like talk. In particular, I think like the co-evolution of like beliefs and networks, I think will be like super interesting to learn from all of these like endogenous like effects. And like finally, I'm just going to like quickly also like mention that I've been also working on like some mechanism design problems where we have like agents who with interdependent values. That just means that like instead of having private values that are independent of each other, our values for the outcomes are actually very dependent on each other's values, mainly because I might not even know how I value an outcome because my value depends on the information everybody has, right? Sometimes my value for an outcome depends on the private information of all the agents involved. So I'm interested in like understanding how to design good mechanisms under these settings. And especially in this semester, I would like to like explore like settings where these interdependencies are coming out of network effects or like peer effects. So yeah, so with that, I'll wrap up. Let me know if you have any questions. Thank you for listening.
Thanks for the talk. Questions?
So the fact that you can add bias means that it lives. Does theta live in real numbers or?
Oh yes. So we are assuming that theta is like any real number, and the receiver actually does not know anything about theta. So she has like an uninformative, like diffuse prior over theta. So we can add a bias and send a signal closest to theta.
But does it sort of generalize to high dimensional theta? Or?
That's a good question. I think that we didn't really explore that. And I think that would be a very nice thing to study, especially if my types are also high dimensional and the way like I will talk to people depending on like which axes I'm like, yeah, I think that's a good question to study, but like we haven't explored that yet.
Oh, I was also wondering, so the sender, so it seems like the sender will want to not be too biased, but so what if the sender is sort of short-sighted, knows when this will end? Maybe, you know, well.
Can you repeat that question?
So it seemed like in the long term, the sender will not want to add bias, right?
Yeah, so like in a repeated game, maybe especially because there is this whole I think you can think of commitment as reputation, and in a repeated game, that's basically what ends up like not making sense for the sender to send a bias signal. But like here we are looking at like what happens like in a one-shot equilibrium where so there is this what happens is that there is a tension between like the persuasion temptation that the sender is having versus sending an informative signal. And it has a very unraveling effect that does stop. So in equilibrium, it doesn't unravel to the extreme. It unravels to some point. And so there is bias in equilibrium. Yeah.
Let's take any other questions offline. Thanks. Yeah. So the last talk of the session and the whole event is machine learning on large scale.